Well, hello, and thank you for coming to today's webinar on industrial control panels. We're just going to wait for a few more people to log in, so give us a minute or two, and we will begin in just a minute. Thank you. Okay, well, hello everyone, and thank you for joining us today for our webinar on industrial control panels. My name is Rob Rallo. I'm a senior engineer at SunWize, and I have been in the off-grid business for over 25 years now. And joining me today is Errol Rankin, who will be helping me also on some of the assembled products at the end of this webinar. So we will be doing a joint webinar on this one today. Okay. Let's see, as always, please ask your questions in the box, and we'll get to those as we go, or at the end, most definitely. And also, this webinar will be recorded and will be available shortly afterwards. Okay, thank you, and here we go. So, for those who are not aware of it, SunWize has been in the off-grid business for over 25 years. And that ranges from standalone PV systems to hybrid battery backup and anything else pretty much to do with off-grid or anything that needs a battery or has questionable power coming to it. We have headquarters in Oregon, but we also have warehouses in New York and a few other places. We have sales offices across the country. And as I mentioned, we do standalone systems. We can do mobile ones, hybrid, cyclocharge, battery backup. We can also just do component cells as needed, as well as custom modules and a few other services and products we provide. Also, as part of the services, we can do some engineering support in terms of training, troubleshooting, installation services, design engineering. That's a big one that people need help with, technical specification writing as well, and consulting. So many of the engineering side of things and services that we can provide as well. And you notice on there industrial control panels, which is going to be today's topic. Okay, so today we're going to cover the control panels. Why are they important? What's needed? What's involved in that? What components are part of it? Overcurrent protection, which is a very important part of the panels. Disconnects, terminal box, grounding, then ratings. Ratings are extremely important. Then we're going to get into some of the charge controller options, accessory panels, and then some of the fitment rules that work with the SunWize enclosures. Okay, so what is a control panel? Okay, and what is it made of? Why do you need it? Okay, the big thing here is that the charge controllers, most charge controllers do not include the other things needed. So you have your modules, you have your batteries, and you have this controller. And unfortunately, you need a little more than that for it to work, besides just the wires that go in between. You're going to need disconnects or circuit breakers or fuse protection of some form, just for safety purposes, and also, of course, just in case there are short circuits or things like that. So you're going to need definitely some type of overcurrent protection and disconnects for safe installation, maintenance, and troubleshooting the system. Okay, and you're also going to need some type of grounding requirement, again, for safety and also for proper operation of the system. And we're going to get into those things in more detail. So you need other things to go with this besides just a charge controller, and that's what we're going to talk about today. So you're going to need circuit protection. You need the wire to put together, Obviously, you're going to have to put the stuff on something, so that's what the backplate is for. Generally, the backplates are designed to mount in an enclosure. You can mount it in an enclosure with the batteries or in a standalone enclosure. Depends upon the size of the system, the application requirements, and things like that. There are other components you can add in there as well. You can add in communication devices. You can add in converters, surge protection, stuff like that. We're going to talk a little bit more about that in this webinar, but for a lot of those things, we have our next webinar coming up next month. It's going to be on advanced controllers. We're going to get into a lot of these optional components and what can work with these charge controllers. That's next month's topic, but we'll get into those a little bit today in terms of some of the simpler stuff that go into our standard control panels. And here's kind of just a quick photo of one. Again, we've got a charge controller on there with circuit breakers, and it's a terminal box. You'll notice the ground bar at the bottom, and it's on aluminum backplate. So again, fairly simple, but also very important. We're going to get in these components, why they're needed, what they do, and what constitutes basically a control panel here. Okay, here's a list of our standard control panels at SunWize. You can see there are various sizes and voltages and several different types of charge controllers. You have everything from a simple sun saver to the ProStars. We have the ProStars with the meters, and we have the ProStars with the MPPT, the maximum power point tracker on it. We also have a 48-volt version using the Phocos Dingo and a couple of the other economy versions from Phocos as well. Again, these are just the standard ones. We can also make custom ones as needed as well, but these are the standard ones that we do stock on the shelf so that we can deliver our product quickly, usually within a few days of ordering. Okay. So the max rating for the standard period panels is a 40 amps MPPT, and that's because it's based upon the ProStar MPPT 40. Okay, and basically at 24 volts, that comes out to about 960 watts. Which means they'll basically support up to a solar array of about 1,000 watts. So you can basically put together a system with standard parts up to about 1,000 watts of solar. Okay. Again, I think we talked this a little bit. Why are they important? Again, they are important because it is you need these additional things to put together. You can purchase it from us pre-wired and tested, which is very good because that way you make certain everything is put together correctly. We can also pair it with some other major components. Again, the converters and things like that if needed, sometimes inverter as well. There are options as well to have custom ones made that are UL 508A if UL is required for the entire assembly. Again, some of these components are UL listed. As a matter of fact, most of the components are UL listed. The entire assembly is not, though, unless it is needed, then we can have it done to the UL 508A. And the other thing is that this can also speed up the installation process tremendously by having this stuff already all done. You really don't want to be wiring this stuff in the field. You really want to make it pretty simple. So it's better to have this stuff done, tested at a manufacturing facility, and then it makes the field installation much quicker. Okay, let's get into some of the details of overcurrent protection. Overcurrent protection prevents things from getting damaged from surges, pretty much specifically short circuits and faults. There can be other reasons to have things like that. If you have a loose wire, you can create a hot spot. Things like that, but it's really there for safety purposes, specifically for short circuit current, but also for things along those lines as well. Okay, it is required on the battery line as an absolute minimum, and may be required on the solar array or the load on the load side. It depends on how big the system is and the coordination of the circuit breakers and things like that. So it may or may not be required on that. Okay, and the overcurrent protection can be either a fuse or a circuit breaker. A circuit breaker can be handy for disconnect purposes. I'll talk about that in just a minute. And it should only be placed in the ungrounded conductor. Basically on the positive side on a negative ground system, or on the negative side on the positive ground system. Okay, but again, it should only be a one line and one line only. You do not want to switch the grounded line. That is a safety violation and can be quite dangerous. Disconnects, okay. Disconnects can be extremely helpful in installation, maintenance, and troubleshooting a system. It's very handy to be able to disconnect the array, to be able to troubleshoot, to do your open circuit voltage or short circuit currents. It's handy to be able to turn the load on and off. So it's great to have disconnects in the system to help you do troubleshooting, installation, and maintenance. Typically, it's found again on the array, battery, and load lines, because these are usually the ones that need to be switched the most. Okay, but again, they may not be required. It depends on how big the system is and the components involved. They can be combined with the overcurrent protection and the circuit breaker. I mentioned earlier, a lot of times it's just easier as a circuit breaker. It ends up being, it's a little more expensive than a fuse, but not much more. But if you're going to put disconnects in anyway, if you combine those two together, you can save some money. So generally, you can use a circuit breaker as a disconnect, and that works pretty well. And again, only place that in the ungrounded conductor. As I said, you never want to switch the grounded line. It kind of defeats the whole purpose of having a grounded line if you put a switch in it or something that is able to disconnect it from the rest of the system. Okay, just another kind of a brief sketch of a panel here. You can see we got the circuit breakers in this one. We've got some terminal blocks for the load output, and this one also has a surge resistor as well for some transient protection, over voltage protection, basically from a lightning strike. You'll notice the ground bar in here as well, and a ground lug. It's going to go to a ground lug on the side of the enclosure, but that grounding is very important. We're going to talk about that a little bit more in just a minute. Okay, so let's move from that into the terminal blocks. Terminal blocks may or may not be required. Some controllers have terminal connections on them, and some have flying leads. You can see in the little pictures down here is a SunSaver that has some nice terminals at the bottom of it. And this is a Phocos controller, and you can see they've got wires coming out of it. So you might want to use external terminal blocks with this to make other, which is a better option than trying to splice the wires with butt splices and things like that. Not a good idea in the field. Those can fail, and they can be a problem. Generally, you want to use terminal blocks. You can take these flying leads to a terminal block if you have a controller like that. Also, the terminal blocks can be used to combine inputs, and it can also be used for distribution, kind of the opposite of that. So if you've got multiple array inputs, it can be used for that, although a combiner box may be necessary. I'm going to talk about that more in a minute. And it can also be used for distribution on the load side. Going back to this one again, you can see here, this is on the load output. And you can see this gives you up to 4 load connections. Generally, you might have more than one load. This allows you to wire it to this terminal box. Okay, they can also be used to increase and decrease wires. Again, this could be handy if you have loads with that might have some type of surge as a voltage drop issue. As you generally found more on the array side, though, where voltage drop can be a bigger problem. So in cases of the voltage drop, you may need to increase the wire size and then decrease it down the line before you get to the controller. So terminal blocks can be very handy for that as well if you have that type of problem or situation. Okay, array combining. If you have more than one string of solar modules, there's a good chance an array combiner might be required. We have a whole tech note on that. I've got the link there at the bottom on whether you need a combiner box or not. But generally, if you've got more than one string, not solar module, because they might be wired in series, we're talking parallel here, we're talking a string. So each output essentially generally probably needs to have some type of fuse or overcurrent protection on it, and that's generally because of the string fuse rating of the solar module. And again, I'd refer you to the tech note on that to get that in more detail. But again, if you're going to have more than one string, most likely you're going to need a combiner. So that combiner box can be integrated into the control panel, or it can be a standalone device. Okay. Here's our examples of ones that can be integrated. This is the one on the right here is an actual combiner box that can be installed out at the solar array, either on the pole or on the structure itself. As you can see, it's got 3 circuit breakers on the input. It's got a ground bar in it, and it's got a bar for the grounded connector to go to as well. Okay, and then on the left is an accessory panel we have for our enclosures. So SunWize has an accessory panel that has the basically combiner built into it. So instead of having to have a separate box out at the pole, you can bring your wires over to the enclosure, and you can have this little combiner panel right on the side next to the control panel. And Errol's going to talk about that more when we get into accessory panels at the end of this presentation. And here's an example of a big panel, a big control panel. Basically, you can see we've actually got 4 breakers on it for the arrays to come into. It's got a bunch of distribution stuff on it for the load. We've got a DC-DC converter as well, so these panels can get rather complex sometimes. This would not be a standard one. This would be a custom one. But again, when you get into stuff like this, it's nice to be able to pre-assemble and test it at a controlled environment before you actually install it in the field. So let's talk a little bit about grounding. I want to clarify there are two different types of grounds. I think people get confused about this frequently. There's what we call a mechanical or chassis ground, which basically grounds the equipment. It grounds anything that's metal, module frames, the back plate, the enclosure. All these things need to be grounded. Okay, and the reason for that is for safety purposes. It's to prevent any type of shock risk. Basically to somebody that comes in contact with these enclosures. You don't accidentally want a live wire basically to come in contact with the metal, and then somebody touches the metal and they get shocked. So that is required to have these things grounded for safety purposes. And again, that's the mechanical or chassis ground, as we call it. There's also the electrical ground, which is different, and that is grounding the grounded conductor. As I mentioned before, that would be the negative and a negative ground system. The reason it's called a negative ground system is that negative is actually grounded. Okay, and that should occur at one point and one point only. If there are multiple ground points, then ground loops can occur. That can be a problem. So you only want to have one ground and one ground only for your electrical system, for the electrical wire itself. That is generally recommended to be as close to the battery as possible, and that's because the battery generally can generate the most amount of current. We're going to talk about that in just a second too when it comes to interrupt ratings. But because the battery is capable of producing so much current, generally you want that ground as closest to it to maximize that. Now, what can happen is sometimes you will have loads that have the ground built into it. If that happens, then you cannot have a ground at the battery as well, because that would be a big ground loop. So if you are forced to have a ground at the load, then so be it. You're gonna have to work with that, and that will be your only single point of ground. But just again, so just be aware of that some loads can have that. If that is the case, to use that as your ground and do not put an additional one in there at the battery. You don't want a ground loop. I've had many times troubleshooting the fields with customers that had created ground loops that caused all kinds of issues for systems with MPPTs and DC-DC converters and stuff like that. So you really only want one point of ground. Okay, and again, it's important, and people ask, well, why do you have to have that ground? And it's for safety purposes, but it's also for proper operation of the system and for surge protection. It's down for a reference point, and most importantly, when it comes to the surge, we're talking transients from lightning surges. If you have a surge resistor in there, or even if you don't, the charge controllers generally have built-in surge resistors in them. They have transorbs, resistors, and things like that. They shunt that energy to the grounded line. Okay, so if that grounded line is not connected to the ground itself, then that energy can't dissipate correctly, and you could damage your controller or something like that. So as simple as actually adding that connection to ground from the negative wire for your negative ground system or positive for positive ground system can actually help prevent bigger issues for your system in terms of it operating correctly and in terms of being able to properly discharge the transients that may occur from nearby lightning or something like that. So again, just real simple to run this little jumper wire over there can help the system operate correctly and make certain you take full advantage of the surge protection available. Just a couple of photos of wires connected to ground rods itself. Even though you have a ground bar and a ground lug on the box, you have to keep in mind this does need to go to earth at some point. And generally the best way to do that is with a ground rod. You can also do it with ground wire buried in the ground. There's also ground plates. There's many methods to do that one. And we have a great tech note on grounding in solar systems as well, if you're interested in reading up on that. You can combine, oh, by the way, you should keep your ground separate. You should keep your electrical ground and your mechanical ground separate until you get to the ground rod or the ground system. At that point, you can combine them together. You don't need a separate ground rod for the electrical ground versus the mechanical ground. You can combine them over at the ground rod. Oh, and the reason to have those kind of separate except for one point, again, is to prevent the ground loop. So if you can bring them to one point, then that's fine. Then you can run that wire from there. But again, you only want one ground for that. Okay, DC ratings. I've seen this happen a lot, and this can be very dangerous. Components in systems with batteries should be rated for DC. Okay, you have to have a DC voltage rating on your components. Switches, fuses, circuit breakers, all need to be DC rated. I have seen people put the incorrect components in there, and it is extremely dangerous. I have literally seen things catch on fire. So you need to make certain that these components are properly rated for that. I mean, the last thing you do is put a circuit breaker or fuse in there or disconnect that's supposed to be there for safety purposes, then put the incorrect one in, and now you've not only defeated the whole point of safety, you've actually created a liability here, because now that thing can catch on fire, and now you have no way to shut anything off. So it's you want to make certain that you have the correct rating on there. Now, what people also forget about is the solar array open circuit voltage can be much higher than the system voltage itself. Again, in a 24-volt system, you may have a open circuit voltage as high as 40 to 44 volts. So you need to make certain that your components are rated for that, and that's before you even adjust for temperature. If you get into cold environments where that open circuit voltage can go even higher, you may need to make certain you have components that are rated at that higher voltage as well. Okay, and again, these ratings should focus mostly on the overcurrent protection, but they can also apply to relays that might be needed for things and stuff like that, other components in the system as well. Everything should be rated for those DC voltages. I mentioned the solar charge controller only because sometimes people do put, especially the maximum power point trackers, they do put too high a voltage of an array on those. So I would also just recommend that whenever you're working with the MPPTs, if you're not certain, most of the manufacturers have programs that allow you to check your solar modules. You can input the solar module and the number of them, and it'll tell you how many you can put in series and parallel for that charge controller. So, and you never want to exceed the recommendation on the number in series, because again, if you exceed that voltage, you can literally set them on fire. I've seen that happen before. So from people that have made mistakes like that. So again, you always want to make certain that you're staying within the DC ratings of the components. Okay. So now, in addition to the voltage ratings, there's also interrupt ratings, and that's something that a lot of people aren't familiar with, but these batteries can put out a tremendous amount of current, sometimes up to 5,000 amps upon short circuit. And that's a lot of power that has to be dissipated in your overcurrent device, in your fuse or circuit breaker, when it has to go. Obviously, if you're in a situation where you have a short circuit and the battery's putting out 5,000 amps, the device needs to be able to interrupt that and safely, in order to protect everything else. So that's why it's called interrupt currents, also referred to as AIC, or amp interrupt current. Okay. Going to go in a few examples of that. And this is just to let you know, the batteries. This is from MK on their 8G battery line, and you can see the column over here all the way on the right gives you the short circuit current rating. So they actually give you that information. Most battery manufacturers should have that. If it's not on their spec sheet, contact them. They can give you that information. As I was saying, you can see on the 8G 8D, it can get all the way up to 5,749 amps at the battery. Okay, just to give you some example of the circuit breakers and their ratings, on the Square Ds, they are rated at 5,000 amps interrupt at the 48 volts. These are also AC rated as well. As I was saying, some are both AC and DC rated, but you'll notice that the DC rating is way below the AC rating. This 48 volts is definitely below the 120 volts. There are a couple of notes with these two as well when you use them in DC systems. I didn't add those notes in there, but you will definitely want to check those when working with AC and DC breakers. Sometimes there are some caveats to that. CBI breakers are another popular one. They're private label by both Midnight Solar and Outback. I think there might be some others. They have both 80 volt and 120 volt DC ratings. Although they are used for 150 volts, there are special testing has been done by both Midnight and Outback to get those up to 150 volts rating. So although CBI does not have certifications for that, both Outback and Midnight do, so they can be used in those applications. These have a 10,000 amp interrupt on them, so that's what the 10 KA is there. So these are rated for that. And again, you can see there's the interrupt capacity on those. They have a little note on those. So the circuit breakers will have this information on them if you look at the spec sheets. And again, if you look at the battery spec sheet, it'll give you that information as well. And just one more example on fuses. These are on the Busman ABC fuses. You can see they have both AC ratings and DC ratings. Okay, you'll notice depending upon the size, they have various AC ratings, whether it's 250 or 120 volts. Okay. What's interesting here is they give actually give two different interrupt ratings for the AC. They give a lower one for the 250 and a higher one for the 125. And here for the DC ratings, they're giving you 10,000 amps at 125 volts DC. And then as you get into the bigger sizes, it's only rated the 400. But those 400s are actually rated at 1,000 and 75. I would not recommend using these for the bigger batteries. These might be fine for like a group 30, 31, or 27 or smaller. I wouldn't use everything bigger than that because that 1,000 amps isn't going to do much for you in terms of being able to protect from the short circuits in the battery. You probably want to go to a bigger fuse at that point. Bigger models, something like that, something I can handle the interrupt rating on that. Okay, let's just briefly go through how to size a charge controller. We've got a tech note on that and a webinar. We've covered this before, but just wanted to briefly go through the formulas, everybody, again. For the MPPT controllers, the maximum power point ones, oversizing the array will not hurt it. Okay, in terms of power, oversizing the voltage will. To get back to those DC voltage ratings again, always stay inside the window of that unit. Okay, but oversizing the wattage isn't going to hurt it any at all. What ends up happening is it just ends up being wasted power. Okay, so generally we would take the current output rating of the unit, multiply it by the voltage. That gives you the maximum wattage of solar. And again, I actually like to oversize a little bit. You never get the maximum out of the solar array, so oversizing it by about 10 to 20% isn't a problem. Because you pretty much generally never get ideal conditions, in which case you can actually get the maximum rating in the solar modules. It's usually a little less than that, usually about 80% of its maximum rating. So oversizing by 10 to 20% isn't going to hurt anything and is fine. Okay, now on the pulse width modulated units, shunt regulators and series regulators, completely different story there. They can't limit the output current. On MPPT, they can actually limit the output current. So because of that, that's why you can oversize. But you have to be careful on the PWMs. They don't actually have any current limiting capabilities. So if you accidentally put too much current on a unit, if you put 30 amps on a 15 amp unit, you will burn it up. Okay, so you do not want to do that. But in addition to that, you also want to add in some safety factors. NEC recommends that you add in 125% for cloud enhancement, okay, from what they call edge of cloud effect, and then another 125% just for safety factors. Normally, that's the safety margin that they usually require you have on most electrical devices. So they tell you to have that, and then add an additional 125% for cloud enhancement and things like that. Okay, same rules apply to circuit breakers, by the way. You definitely want to follow that for NEC. Okay. On the MPPTs, it's a little weird, actually. There's a kind of a weird rule with those. And again, I think we have a tech note on that as well. If you, because the MPPTs limit the output current, you can actually use a breaker rated at that. So if you have a 60 amp MPPT, you can actually use a 60 amp circuit breaker with it, if that breaker is rated to 60 amps at 100%. And without tripping, then you can go ahead and use it. There's a weird clause in the NEC that says you can do that. Generally, we like to put a little bit more safety margin in there, just going to stay aside. So if we had a 60 amp unit, we might use a slightly higher breaker, just so that there isn't any nuisance trips. Okay, and again, I mentioned the voltage. Definitely make certain you have the breaker is designed and sized for the correct DC voltage that will be happening in your system. I was showing those square Ds before that are rated up to 48 volts, which is fine for a 12 and 24 volt. You certainly will not want to use that in a 48 volt system, though, as the batteries can go up to 60 volts, and the array can go even higher. It can go to 80 and 88 volts. So you certainly will not want to use one of those in a 48 volt system. Okay, getting into some examples here. A lot of times people use glass EGC fuses in these systems. They should not be used at all. A lot of times you'll see people use them in inline fuses or in really small systems. They use them because they're cheap and easy to get. You can buy them almost anywhere. The problem is they are not DC rated, they're AC rated only. That's why I showed you the chart with the ABC fuse instead. They fit in exactly the same holder. They are a very similar design. The difference is they're not glass, they're ceramic. And because of that, they have a DC rating on them. They're rated actually 125 volts DC. So again, Be very careful of that. Make sure the components you're using are DC rated. I mentioned the QAU breakers also before. Again, they're all rated to 48 volts, so you don't want to use on a 40-volt system. Here's just some photos of some competitors of what not to do. You can see they actually have a single fuse only on the battery line, and those fuses are actually glass, by the way. I know you can't see that from the photo, but they are, so you definitely don't want to do that. They have no additional terminal blocks at all for making connections for multiple loads or arrays or anything else. And they don't even have any place to ground anything. They have a ground wire coming off the back plate going outside the box, and that's it. So there's no place to bring your ground wires together to ground your battery or anything else. So this is kind of example of what you probably don't want to look for in a control panel. It's just simply a back plate with a charge controller and a fuse, and there really should be a little bit more on that. You should have some additional disconnects, overcurrent protection, and definitely some additional grounding locations as well. Terminal blocks for multiple loads and arrays and things like that. Okay, I mentioned before the types of charge controllers. We have webinars on that. If you want more information on that, it gets into the charge controller some more, in addition to how to properly size those. And a lot of other stuff I've covered here we have webinars on and take notes on our website for. And just another plug for the Advanced Charge Controllers webinar, which will be coming up on March 14th. I think that's going to be a really good one for a lot of people to enjoy. It goes into great detail of what you can do with some of these charge controllers. And even myself, as I was getting ready for this webinar, learned a couple of things you can do with a charge controller I didn't know you can do. So even those of us who have been in this business a long time, every now and then we stumble across a feature that a controller has that we didn't even know it had. So that's coming up in 2 weeks on the 14th. And I'm going to turn over to Errol, and he's going to cover our standard PRE control panels, what's in them, and all about those, as well as the accessory panels you can go with those as well. The accessory panels are pretty cool. They allow you to mix and match stuff and probably cover about 90% of the systems out there you'll be able to cover with standard off-the-shelf parts from us.
Awesome. Thanks, Rob. I really appreciate that. That was really good. Again, my name's Errol Rankin. I'm a business analyst with SunWize, and I'm going to be talking a little bit about our ecosystem of systems and control panels and enclosures and how all those things fit together and why they're important and how you can leverage the information that we provide to our customers to optimize your designs and your part selections. All right, so the first thing that we're going to talk about is what we have as our accessory I/O panels. These are meant to complement our standard express panels, our Power Ready Express control panels that we talked about at the beginning of this presentation. That covers the primary line of SunSavers, ProStars, SunSaver MPPT, ProStar MPPT, and some Phocos products as well. So the standard Power Ready Express control panels and systems are meant to service the loads and applications that run at nominal DC loads. So what that means is if you have industrial equipment that can handle a range of voltage inputs that come off of a nominal 12 or 24 volt DC battery bank, then our standard control panels and our standard systems will work right out the box. Now, as you get into more advanced applications where additional features and functions are required, we have introduced this accessory I/O panel line as a capability, as a way to be able to achieve these extra features and functionalities through modular building blocks. So the ones that we're going to review right now, the major ones that we have released and data sheets for on our website are up on the screen. So that includes a timer accessory panel. Talk about that. A 3-pole combiner that we reviewed earlier on this presentation. We even saw a photo of that, as well as a side plate that can be used for 200 watt AC loads and below from a 200 watt single phase inverter, as well as regulated DC loads that are under 25 watts. So what these accessory panels do is it allows us to solve standard load problems or standard load scenarios, not just at the nominal DC 12 and 24 volt range, but also through single phase AC loads that are under 200 watts, as well as any regulated DC load at 12 or 24 volts that's under 25 watts. So that could be a tolerance as low as 1% of the voltage or less. So those are what we're going to go over, and we're going to explain how they fit and what they allow you to do. Okay, next slide. So as I mentioned, the idea behind these accessory I/O panels is that they're plug and play compatible with any other SunWize PRE control panel that we reviewed on slide 10. What that means is that if you have a standard load and a system, but it's a 100-watt AC load, then all you need to do is purchase the control panel plus the AC accessory panel, and now you have everything that you need electrically to plug and play and go for your project. All right, next slide. So the first one we want to talk about is the accessory panel. So what this is it has a Cotek timer pre-installed on the side plate. And this is a fully digital programmable timer with buttons and LED control. It allows seven-day, 24 hours a day timers. It's got multiple profile controls. It's a relatively advanced unit, which is a great way to cost effectively add timed load control to just about any device in the field. If you want to run devices only certain times of the day, of the night, scheduled through certain periods of the week, this is a really excellent way to do that. Allows you to control your load consumption from your devices much more tightly, potentially reducing the overall size of your system and cost if you're not running the load in time periods where it's not necessary. Okay. Next slide. So the next one we're going to talk about is the inverter accessory panel. This comes in two versions, either a 12-volt DC nominal voltage or 24-volt DC nominal voltage version. They're both rated for 200 watts continuous output. They'll operate at either 50 hertz or 60 hertz frequency, single phase with an output range of 100 to 120 volts AC.
We also, I'm going to jump in just a second. We also have two other versions of these that include a relay, and that relay can be controlled from the charge controller. If you want to do time of day or something like that, if you say you have AC lighting, you can use this, and then you can control the relay on and off from the say a ProStar or something like that. So we have an option for that as well, in both the 12 and 24 volt.
Thanks, Rob. That's great. All right, so the next panel that we're going to talk about is the converter accessory panel. This includes the Meanwell SD series DC-DC converter. This again comes in two configurations, either a 12 to 24 volt converter option or a 24 to 12 volt converter option. So for instance, one of the great applications for this would be if you had a system that had two loads, and one of the loads ran off of a nominal 24 volt battery bank, but then you had another load that required a very tight voltage tolerance at 12 volts DC. Typically, but not always, certainly, a lot of these regulated loads are quite small. So if you did have a scenario like that where you had a nominal 24 volt DC load and a regulated 12 volt DC load that was less than 25 watts continuous, then you would simply purchase the control panel to support the load or system in question along with this accessory panel, and now you'd be able to run your 24 volt DC nominal load as well as your 12 volt DC regulated load simply using two part numbers. Now again, if you had a 24 volt DC nominal load and a 24 volt DC regulated load, you'd simply choose the other converter accessory part number. One of the other nice features that this has is it sort of has a dual functionality that also serves as a two-string combiner. So going back to the array combining options that we talked about as either being on the control panel or being a separate combiner box, if you are in need of a scenario of only a two-string combiner, this could be used for that purpose or coupled with the need for a DC-DC converter as well. All right. So one of the important things to understand about using and leveraging our pre-wired panels, which even our most sophisticated customers really rely on us for, because it just makes a lot of sense for the expert panel shops to be assembling, QC, testing these systems ahead of time, is figuring out and understanding how they fit in our various enclosures. As we will sort of see and understand, and as people that have been familiar with these sort of equipments and designs for a long time will know, one of the interesting things about a control panel is that in a lot of ways, the control panel itself defines the entire system. And what I mean by that is that within the control panel backplate, your backplate dimensions automatically dictate the maximum size charge controller that can be placed on that backplate, which in turn automatically dictates the largest size solar array that can be configured with that charge controller. So just right off the bat, you've basically defined your upper bound for your solar array just by choosing your charge controller or your industrial control panel. Similarly, on the enclosure and battery bank side, the footprint of your control panel and the mounting hole locations and the physical specifications of that will dictate what enclosure that control panel will fit in. The fitment of the enclosure, in turn, dictates how many batteries you can fit in that enclosure, which defines your total energy storage of the system, which provides the secondary bound on your total system size. So just by choosing a charge controller panel, you have instantaneously, in effect, set the upper bounds for both your array and your battery bank. So understanding how those control panels fit and what the ratings are and how that dictates your solar array size can really help you get an understanding of best design practices very easily. Okay, so next slide. So that was all a preface for understanding what we call our universal backplates and our universal side plates. So what's important to understand is that our PRE control panels, the ones that were reviewed on slide 10, that include every permutation of SunSaver, SunSaver MPPT, ProStar, ProStar MPPT, Dingo, and EcoNT from Phocos. Every single one of those control panels will fit on every single one of the enclosures listed under the universal backplate section on the left. So what that means is that when you choose any Power Ready Express control panel, you know right off the bat that that Power Ready Express control panel will fit on the backplate stud mounting locations of our M131, M11AD, M28D, our standard F-series enclosures, our C-series enclosures, and our T-series enclosures. Right off the bat, plug and play, very easy to do. Secondly, all of our I/O accessory panels, the ones that we were just reviewing for the inverter side plate, the DC-DC converter side plate, those will fit on the side plate mounting location of our various enclosures. So knowing our back plate fitment rules and our side plate fitment rules allow us to mix and match the right control panel with the right I/O accessory panel to any one of our enclosures, with the control panel going on the back plate and the I/O panel going on the side plate. Okay, next slide. So another thing I want to talk about that ties closely into this is our radio shelf product. Now, this radio shelf product is extremely handy for our customers to be able to set or place their own power electronics. That's usually the equipment that our systems are powering, but it could be auxiliary devices that serve a separate purpose on site, or non-load consuming equipment. It could be a variety of things. This shelf is simply a flat surface. You could place stuff on it. It doesn't have any bolt hole or drill holes or anything like that. So it's simply a shelf that can be used to store equipment in the enclosure. Very handy for radios, networking equipment, all that sort of stuff. It will fit standard in all of our front opening enclosures, so our M, F, and C series. You'll note that there is a note there on the M18D and the M28D. Those are the only enclosures that will fit the radio shelf and the side plate simultaneously. So what that means is that if you have an application where you need to use an I/O accessory panel, or you're using a side plate for a custom application, you can purchase those side plates with the drill hold patterns already completed as standalone aluminum backplate products. Then you'll need to either choose the radio shelf or the side plate unless you're using those two M series enclosures. They basically serve the same purpose in the sense that they allow for additional equipment in the system, usually power conversion equipment, but it could be a variety of things, to rest within the enclosure in that protected environment. The major difference is that the side plate typically has the drill holes and is actually drill mounted, whereas the radio shelf is just placement. Okay. So the next thing I want to talk about really briefly is our WF series enclosures. Up until this point, we've been talking about standard products. These are sort of off the shelf, readily available. You can order them online. On the WF series, the enclosures and the backplates themselves are obviously standard products, but the control panels themselves are almost strictly custom applications. If there are custom control panel requirements, this is a very popular enclosure for us to use. The backplate has the capability to take up nearly the entire back real estate space of the WF2 enclosure. Rob, I know that these are very popular in some of our hybrid applications when a larger controls area is necessary to interface. This is a really great standalone option that can be pole mounted or pad mounted to provide really good controls real estate space. All right. So the last series I want to talk about really briefly is our T-series enclosures. Now, again, remember that the standard control panel sizes will fit in the T-series enclosures. So you can purchase any Power Ready Express control panel and put them in any T-series enclosures. However, the T-series enclosures also have their own line of backplates. And those backplates come in two options, the universal T-series backplate size and then a large size. These are simply larger backplates that take advantage of the additional real estate options available in the T-series enclosures. So for custom applications where TriStar and TriStar MPPT controllers are required, or other controllers in the 60, 80 or above amp range, then we will use these oversized backplates for those applications. But they do not come with any standard part numbers at this time.
Actually, there's a third option as well. If you're using the 4D or 8D batteries, not the L16s as are shown here, but the 4Ds or 8Ds, you also have a third option of a component tray that sits above the batteries that allow you to put components in as well.
That's correct. Yep, we've got a couple tray options, and actually there's even a top mounting backplate that will fit in these T-series as well that can go on the roof. So really a ton of mounting flexibility and design options in our enclosures, and really the fundamental fitment and compatibility check for the entire system begins at what fits on the control panel and what enclosure does the control panel fit in. Once you have those two questions answered, everything else just sort of falls into place really easily. So understanding the offerings that are available and how those can be utilized and mixed and matched by our customers, we think is extremely important. And this just goes to hopefully show that purchasing a control panel really only leaves you with 4 or 5 other components before you have a complete functioning system, even to support regulated DC and AC loads as well. Okay, next slide. All right, so I want to briefly talk about the control panels for battery backup applications, which are really pretty similar and analogous to a lot of the control panel topics that we've talked about so far. Really, the fundamental difference from a high level mostly is that the solar charge controller is swapped out for a battery charger. Now, one of the effects of this is that typically in a solar control panel application, the LVD is included within the solar charge controller. Now, not always, but oftentimes it is, especially with the SunSaver, ProStar MPPT lines. If you take that away and you now have a dedicated battery charger, then you still have a need for a low voltage disconnect in order to protect your batteries from the load. That doesn't change in a battery backup system. So now you sort of have a solar charge controller that morphs into a battery charger plus a load controller, but everything else more or less stays the same. Okay? So to go along with this, we're sort of announcing that we are in the process of releasing our POR control panels. So that will be a new line of control panels similar to our PowerReady Express control panels, but these will be dedicated and focused on battery backup applications. So very analogous to the PRE control panels, but for backup applications. These will still be compatible with our IO accessory panels, although there will be some different fitment rules based on the way that these POR systems use equipment trays and various side plates for the power electronics. So this line will support up to 80 amps charging at 12 volts DC or 50 amps charging at 24 volt DC, and they'll be primarily based around the Cotek CX series battery chargers, which we really, really like. And we're excited about that lineup and should hopefully open up some new avenues for our customers to start building and configuring some of their own systems if that is the desired or necessary business model for our customers. We'd love to pre-assemble and build as much stuff as possible for folks, but we understand that's not always realistic, and there are customers that have their own panel shops or their own source on solar modules and batteries, and having these pre-wired control panels really opens up the flexibility on what people can do design-wise.
I'd like to also add on the Cotek CX chargers, they were also just recently UL listed as well, so they're also UL now also.
Yep, great point, Rob. Thank you very much. All right, so here is an image of what one of the POR battery backup control panels is going to look like. This one itself is one designed for our T-Series enclosures. So this is shown on an equipment tray. So these trays will fit over the batteries on our T-Series top opening enclosures. You can see that we've got the Cotek CX battery charger, we've got our circuit protector and terminal blocks on our DIN rail, and then we've got our LVD in a SunSaver. So basically everything that you need to couple with an enclosure and a battery to provide a DC UPS system for any DC load at 12 or 24 volts. So really pretty easy, just 3 part numbers, a control panel, batteries, and an enclosure, and you have a working UPS system for DC loads. Add in an accessory panel, now you've got a DC UPS for AC loads. Okay, next slide. So again, just to reiterate, control panel, batteries, enclosures, 3 SKUs, complete UPS system, outdoor rated, pretty simple. All right. So that's basically all we have. We do have 5 minutes left for some additional questions. I've tried to answer a few folks on chat as I've been talking, but we'd be certainly happy to go into more detail on anything either on the control panels or the enclosures. I know there was some questions on venting and waterproofing of the enclosures. If anybody has questions on NEMA 3R or other enclosure ratings, we actually do have a link on our website on enclosures. Under the learning dropdown, the last link is called NEMA enclosure types. So if you would like to understand more about NEMA 3R and what its protection ratings are compared to, say, NEMA 4 or NEMA 4X or any of that, that's a great document starting place. And then if you have further questions, we'd be happy to answer that as well.
I'd like to also just reiterate that you need to be careful. You should never install batteries in a sealed enclosure, which NEMA 4 and 4X are. So those people that do it should be using some type of breather vent to allow any buildup of gas to get out. So you should always have a vented enclosure of some form for the batteries, and hence the reason our enclosures are NEMA 3R that allows. And actually, technically, they really need them in 3RX because they are aluminum. They're powder coated aluminum, so they are technically corrosion resistant as well because of that. But the idea is that they don't allow, they are designed for outdoor use, but still allow ventilation of the batteries in the event that there is any gassing of those batteries.
All right. I would like to give folks just a couple minutes if they are formulating any questions, or if you are hesitant on the fence, don't hesitate. No such thing as a dumb question. So I'm going to hang tight here for a couple of minutes, just make sure that folks do have time to put in any requests or questions that you have.
And again, just a reminder, our next webinar is on March 14th. It's going to be on advanced charge controllers. We're going to cover things like generator starts, some of the additional features you can have. We're going to briefly touch lighting control, but we've got a whole other webinar on that as well already done. But just some of the really neat things you can do that you might be aware of, how you can have multiple array controls off of one unit, things like that. So if you're interested in some of the advanced features of the charge controllers, or just to have an idea what you can do, even if you don't need it right now, I'll just give you hey, these are things that might be possible. You might not have an application for it today, but maybe in a year or so you come across and go, hey, I vaguely remember something about you could do that with this unit or something like that type of thing. So it's going to be a good one for that.
I will plug one more time as well that we actually do have some handouts. I haven't really mentioned them. These are just the most up-to-date data sheets for our enclosure catalog, which really kind of has every detail you'd ever want to know about our enclosures, as well as all of our control panel data sheets and the data sheet on one of the accessory panels, the inverter side plate accessory panel. So if you are curious or don't have those data sheets or know where to find them on our website, feel free to download them so you have them handy here.
Well, if there are no other questions, thank everybody for your time. Hope you enjoyed the webinar. Hope you learned something. And I have to laugh as usual. We spent the first 30 minutes talking about all these things you need to know, and then we spent the next 30 minutes about, hey, you can forget all of that and just buy the complete unit from us. You don't have to think about that stuff. We'll take care of it for you. So, but again, it's nice to have the background behind it, so you understand that there's a little more to it than you think there is, so that when you are buying these products, you realize the value behind it, some of the engineering involved. And it also helps you, as I pointed out, what you might not want to buy from a competitor. So sometimes it's nice to know what the differences are, what it means, and things like that. So sometimes just have a nice sort of the background, even if you are going to buy the, buy it from us and have to worry about those other things you really need to know then. So thank you all again, everybody.
Appreciate the time, and if there are any further questions, please use the contact form on our website, and we will certainly get back to you on any requests or topics that you may have.